the last half of Chapter 5.5, brought to you by Lego Rebel Pilot, I believe here. I'm not familiar with these as much. So we previously solved exponential equations. Now we're going to solve equations that are logarithmic. And how you tell the difference is, do you see log base a of x in the equation? That's a logarithmic equation. Note you could see log x, which is log 10, or natural log x, which is log base e. So the goal here is to get a logarithm with a coefficient of 1 equal to something else on the other side, preferably a nice, neat number. So let's start with a real basic example. I'm going to do analytically on all of these, and then I'm going to switch to Desmos and show the graphical method. So in this case, this first question A, this is log base 10 of x equals -4. Now, there's two ways we can handle this. One of the ways is, let's just rewrite this in exponential form. So recall, b to the k equals a is true if and only if log base b of a equals k, and these conditions on these things was our b had to be greater than 0 and our b could not equal 1. So this is in this logarithmic form. Note the base here is 10, that's our b. The x is our a, the -4 is our k. So if I rewrite this piece in our exponential form, we would be writing 10 to the -4 equals x. And voila, we're done. That's the answer. If you wanted to, you could rewrite this as 1 over 10 to the 4th, which is also what? 1 over 1, 2, 3, 4 of these, 1, 2, 3, 4, which is also what? 0.1234. All of those things mean the same thing. I'm perfectly happy with this. My stat lab might prefer something else. So I'm going to do all 4 of these problems, and then I'll show you Desmos for each one first. Do all 4 analytically. All right, we're going to apply the same solution method to this logarithm as we did here, because we have a logarithm of something equal to 3. Note its base is 5. So we're going to say 5 to the 3rd power equals what's within the logarithm, 8 minus 7x. That's simply applying our definition of a logarithm. Now from here, this is easy peasy solving, right? This is just a linear equation. Note that 5 to the 3rd is really 125. And then we're going to subtract 8, divide by 7, and away we go. So when I subtract 8, oh, this is getting embarrassing. Yeah, that's 117. When I divide by -7, that's 117 over -7. So there you have it. That's our answer. Oops. Yeah. Again, we could get decimal versions of that and whatever. So this is the basic goal. Any problem you have, you want to get it down to a logarithm equal to a value, because then you can just apply the definition of logarithms. So take a look at these next two. Well, let's just talk about C for a second. Note we have 2 logarithms here and another logarithm on the other side. So our goal is to condense these 2 logarithms into a single one, then we'll have a logarithm equal to something. By the way, notice log 10 of 2, so common log of 2 here, that is just a number, albeit an irrational, not very pretty number, but it's still just a number. So if you recall from section 5.4, I believe, when you see subtraction, we can condense that into a single logarithm of the division or the quotient of what we're evaluating log of. In other words, x plus 5 divided by x minus 3. This is the same representation of the previous thing. Now, note that the bases of these logarithms are exactly the same. So we can ignore the logarithms for the moment, and we can solve this rational equation back from chapter 4. And to solve this one, let's just do the old cross multiplication thing. We have a fraction equal to a fraction, so we'll do this mess. 1 times the left side equals x plus 5. 2 times the right side, I'll write this out to be careful. A common mistake is people forget to distribute. Make sure both things are times 2. Note this is a nice linear equation, but notice this equation allows x equals 3 to be a solution, where back here x cannot equal 3. So we'll just keep that in mind when we finish solving this one. All right, so x plus 5 equals 2x minus 6. Let's collect the x's on the right side. So that would be 1x when we subtract, and we'll collect the numbers on the other side. That would be 11. So there we have it. That's a nice, neat solution. We should double check it, but I'm going to check it graphically when we show the graphical solution. And really, in all of these problems, we should double check that there aren't extraneous solutions. Because remember, what we evaluate log of has to be a value that is greater than 0. Okay, last one is just a reminder of what does ln stand for. It's a very common notation. So let's get this natural log by itself. So we're going to subtract 1, divide by 4. So we'll do these step by step. Subtracting 1 gives us 16. Dividing both sides by 4 gets us 4. And then at this point, we're back to the same state we were up for these two. We have a logarithm equal to something. So note the base of this. We would raise the base of this logarithm to this value, which is an exponent, and that's going to equal x squared. So we have e to the 4th equals x squared. Note, this is just a number. Remember, e is like 2.71 something something. It's Euler's number. So we've raised it to the 4th power. Since we have an unknown value being squared, we're going to take plus or minus the square root of both sides of this equation, and our solution is plus or minus e squared. Now, we should double check that both of these solutions are valid in here, but a real quick glance notes that they will be. This -1 is the only one that could be an extraneous solution, but because we're squaring a negative value, it becomes positive, and we don't have to worry. There are two solutions. All right, let's confirm that all 4 of these equations do indeed give us the values we want by checking them graphically. In other words, we're going to solve them graphically. I'm going to use the x-intercepts method. So I'm going to set each of them equal to 0 and solve. So I'll have log x minus 4, and I know that's supposed to equal 0. And oops, it shouldn't be -4. My apologies. It should be +4 because it was -4 on the left side. All right, so all we have to do is figure out where this cross 0. From our solution, we know it's a really tiny number. Oh, and there it is, 0.001. That confirms what we got analytically. So for B, you're going to have to click this thingy to get the functions. Go to miscellaneous. You want log base A, and we're doing log base 5 of 8 minus 7x. Oh boy, that needed to be in the parentheses. Try again. 8 minus 7x. And then there was a 3 on the other side, so I'm going to subtract it. And our goal is to see where does this thing cross the x-axis. We knew from our analytical method that it was supposed to be at -117 divided by 7. So let's just confirm that our 117 divided by 7 is in fact the same thing that this is showing as a decimal, and it is. Note I just didn't put in the negative, so there's your negative. Okay, good. Everything we've done so far is correct. All right, the last one was the C was a little bit crazier. We had log of x plus 5 minus log of, oh boy, what happened there? Log of x minus 3, and then that was equal to log 2. So I'm going to subtract that to the other side. So all I have to do is look at where does it cross the x-axis. In other words, the intercepts method. And note it crosses the x-axis at exactly 11. That was the solution we had found analytically. Again, so far, I'm on top of my game. Okay, last one. We had 4 times the natural log of x squared. Notice I just typed ln into Desmos, and it handily figured out what it was. This was +1, and then it was equal to 17, so I then have to subtract the 17, and I got 2 solutions. Remember, it was plus or minus e squared. So, oh look, here are our 2 solutions. Let's confirm that e squared is in fact those values. So we'll just type in e squared. Note it's 7.389 something something something, and there it is on Desmos.